All right, hello Year 12s. Got a couple of questions that I can do for you on this video. The first one here is student requested. I've already done it, so I'm going to take you through it just to save a bit of time. And the next question is also student requested. This is question 8 on the same page. So let's going back here. This is 15B, question 5B. That is on page 570. Yes. All right, let's read it out. A fair die is rolled 6 times. Part A, find the expected value for the number of 6s obtained. Just remember, expected value is kind of like the average, right? So if you rolled a die 6 times, right? You rolled it 6 times. How many times would you expect to roll a 6 if you rolled it 6 times? Okay, and so we've got this formula here. We already had a formula for expected value, but we've got a different one this time, and this is on page 569, okay? And this is for the expectation of a binomial random variable. Binomial being we have 2 choices, right? A success and a failure. And in this question, our success is landing on a 6, right? That's our success. And a failure is anything but the 6, right? So it's the number of trials, which there are 6 trials, and the probability of landing on a 6 each time is 1/6. That's just, just using our knowledge of basic probability. So we multiply them together and you get 1, right? 6 times a 6th is just 1. So this here is the expected value for the number of 6s obtained. Makes sense, right? If you roll a dice or a die 6 times, theoretically, right, you'd get a 1, a 2, a 3, not necessarily in this order, but in a perfect world, you'd get something like that, right? And so you'd get 1/6, which is what we just found there. Part B is a little bit more complicated. Find the probability that more than the expected number of 6s obtained. For example, let's use the laser. What if you rolled this? 1, 2, 3, 4, 6 and 6, right? There's 2 6s now, right? And you can see there's many combinations in which you get 2 6s. What if there were 3 6s? What if that was a 6? All right, so there's many combinations there, and we can use a formula for that. And we've got a formula, right? And again, if you've got your textbook with you, it's on page 562. Okay, this is the binomial distribution formula. And what do we need for the binomial distribution formula? There it is there. We need the number of trials. We need the probability of each trial. We need to know the random variable that we've got, and our random variable is the number of 6s that you might obtain. And what are we interested in with these number of 6s? How many number of 6s are we interested in? Well, it says more than the expected number of 6s is obtained. So what is more than the expected number of 6s? Well, we know that 1 is the expected number of 6s obtained. We worked that out here. So we're interested in more than 1. So it's either going to be 2 6s, 3 6s, 4 6s, 5 6s, and 6 6s. And so you can see this is going to be a cumulative example of this binomial distribution. And so when we use this formula, we're going to use this formula, but our x here, and our x here is going to change each time we use a different value of x. So we're going to put 2, 3, 4, 5, and 6 in. So you can see the probability of 2 is accounted for here. The probability of getting 3 6s is accounted for here. The probability of getting 4 6s is accounted for here. 5 here, and 6 here. They all look very similar. See how they look similar? We're using the same formula. We're just putting in a slightly different number into each position. And so I've used this example before in another video, so I won't take you through all of the mathematics that can be found on another video. But essentially, this is 6 choose 2. And so you would do or you would use the formula here of 6 prime, right? 6 times 5 times 4 times 3 times 2 times 1 divided by 2 prime multiplied by 6 minus 2 prime. And then you'd multiply that by this, multiply that by that, get an answer for that, and then do the same thing for these 4 groups as well and add it all together. And you get this, 0.2632. That is the probability that more than the expected number of 6s is obtained. So it's roughly a 1 in 4 chance. That's 0.25 to be exact, but it's slightly higher, so slightly higher than a quarter's chance. All right, so that's the first question. The second question, a binomial random variable x has a mean of 12 and a variance of 9. Find the parameters n and p, and hence find the probability of x being 7. Okay, let me go ahead and suggest that you go to a particular page, and it is page 569. I'm going to go ahead and write a couple of things. These are 2 formulas at the top of 569. Now the formulas for expected value. So expected value is the number of trials multiplied by the probability of each of those trials. And we've got the formula for variance, which is, again, n multiplied by p, but then we multiply that by 1 minus p with the difference. Okay, I hope you can see now, what do we know? Let's write down what we know. Well, we know that in our particular question here, we have a mean of 12. Guys, mean of 12 is expected value. That's the same thing for this question. So we know that this is 12. Mean, expected value, same thing. And variance is 9. So I'm going to write variance is 9. These are 2 facts that I know. Now what I can do, a bit of a trick here, is I can use this idea of simultaneous equations. I can go ahead and do something a little bit tricky, and I can let this portion, this part of the variable formula, right? This part, I can let this equal what this value is. I hope you can see why. First of all, we need to agree that EX, which is our expected value, is exactly the same, right? There's an equal sign there. It's exactly the same as NP. So these 2 things are equal, right? They're the same. So when we see NP down here, we can just replace it with this term here. So I'm going to write this again, except I'm going to replace this with this. All right, my working will be below. All right. So therefore, variance is equal to expected value multiplied by 1 minus p. And so now what I'm going to go ahead and do is replace our variance and our expected value with the actual numbers that have been given in the question. So 9 equals 12 multiplied by 1 minus p. I got some ugly brackets here. These brackets are making it a little bit complicated, so I'm going to go ahead and expand. So let's go ahead and do that. 9, oh, let's not use my laser. 9 equals, all right, so 12 times 1 and 12 times negative p will give me 12 take 12p. I need a bit more room, so I'm going to go over here. And so what I'll have here, I'll write it again. 9 equals 12 minus 12p. So I'm now just trying to find p, aren't I? Because we were in a situation originally where we had, a couple of variables here, and we nailed it down to just 1 in the end, which is what we want to do. because you can't find two variables at once. So here we go, let's do it. I'll take this 12 over to the other side, and it'll become -3, because 9 take 12 will be -3. Okay, let's take this over. -3 over -12 will give us P, and so therefore P will give us positive 1/4, or 0.25. I better write or. There we go. And so if that's the case, if we know that P is 1/4, we can just take this, right, knowing that P equals this, and we can just go ahead and put P as 1/4 in here. We know we know expected value is 12, so if that's 12 and that's 1/4, we can work out this. We can work out what n is. So let's go ahead and work out n. So just think back to our question. We've just worked out P. We've got to work out n now. Okay, so let's do that. So e to x, or expected value, equals np. So substituting, we know that ex is 12. So 12 equals n times p, which we now know is 1/4, or 0.25. Right? Let's go with 0.25. This here is just multiply. All right, to find n on its own, we just transfer 0.25 across, and then we divide by 0.25. So 12 divided by 0.25 equals n. Therefore, n equals, that should be 48, but I'll just confirm with my trusty calculator. 12 divided by 0.25 equals 48. So now we know what n and p are. Let's go ahead and finish the last part, and hence find the probability that x equals 7. I'm going to go ahead and shrink all of this work here. Give myself a little bit more room. Let's go ahead and just make a bit of a space. Okay, so now that we're here, we need to try and work out how we're going to do this. And the way that we're going to do this is by using the binomial distribution formula. And I'm flicking through the page on our textbook, page 562. Here's our formula. I've already done a question for you on YouTube with it, but we'll write it again. The probability that our random variable is equal to some particular set or number in that set is equal to n choose x. So from n number of items, choosing a particular number within those items, how many, what's the probability, or how many possibilities are there within that, multiplied by the probability of that event raised to the power of x, multiplied by 1 minus p, that's the difference left over in the probability, to the power of n minus x. Okay, let's go ahead now and work out the probability that our random variable is not just equal to x, but equal to a particular number equal to 7, as defined by our question. So let's go ahead and do it. All right, we know n. We just worked it out, didn't we? N was 48. So 48, choose x, which is 7, again, as defined by our question. Multiplied by the probability. What's the probability? You guessed it. The probability is 1/4, or 0.25. Raised to the power of 7 times 1 minus the probability again to the power of 48 minus 7, which is 41. Okay. You put that into the calculator and it would look something like this. So 48 prime divided by 7 prime multiplied by 41 prime. That part there is that part there. Multiplied by 1/4 to the power of 7, multiplied by 1 minus 1/4 to the power of 41. Put that in the calculator, and what do you get? You should get 0.0339. Right, thanks for watching, guys.